Hello grade 12s, welcome to my channel. I hope you guys are doing great. Otherwise we have some work to do. So this is what I would call algebra for the Bozzas, okay? The big ones. So let's see what we can do here. So I decided to take an old question paper so that we can showcase some of the skills needed to deal with some technically challenging questions. Not to say they are too difficult, but they certainly do poke your brain a bit, and at times you might feel like you're getting hit. But you don't have to cry. You just have to be patient with the process of pain so that you can understand what it feels like. And once that is in check, then you can start to see opportunities beyond the pain. So I wanted to use the level of this paper just to highlight some higher order questions that you may have to deal with. Because remember, in that time, these kind of exams, most of the questions were very new questions you have never seen before. And even questions that were a bit of a stretch of what was taught in class in general. So it kind of was, very, very, very scary stuff. But I mean, we figured a way of dealing with it. And here we are showing you guys, because the bulk of your exams, guys, is just the standard stuff, usually. It was the case even back then, but usually some questions were usually very strange. Because even a very common question could be asked in a way that is somewhat strange-ish. And in fact, I'll try to highlight where would you be needing to use these kinds of skills, or at least expecting a similar group of questions in this question paper. Of course, we're not going to do it all, but we'll just try and do as much as we can. So folks, instruction number 2, very important. Instruction 4, very important. Essentially, answers should be rounded off to 2 decimal places. Very important to keep in mind. Okay. So now we read the rest of the instructions, of course. Make sure we understand each one so that we don't lose marks by not following instructions, having performed the correct calculations. So let's just start off nicely with question 1. So we know that we will be handling some form of quadratics in different formats. So we know what to expect, but sometimes it is put in a way that can be a bit naughty. So we've got the absolute value of x minus 7 is less than or equal to 1. Now, the best way for me is to write this in standard form, or at least in a form that I can use to solve this question easily. Okay, this absolute value thing is crazy. I transpose the 1, because remember, with inequalities, the target is to always isolate, the 0. Now guys, what we understand is that if we look at this, think of this format: f of x is equal to a into x minus p plus q. So it fits that description. So there's some relationship, or should we say there's some striking resemblance in what we have, and so it can function the same way. So we know that this would be the minimum value of our absolute value function. Okay, all right, okay. And technically this becomes the axis of symmetry there, if we think about it, the opposite sign, which is going to be 7. So anyway, we know that we can actually graph this thing to avoid unnecessary stress. But graphing is not as easy as it looks, so one has to be very careful on what they are doing. So we've got our origin there, just a normal Cartesian plane. So what do we do, guys? First, we need x-intercepts. Now, this can be done as a separate calculation in the rough work. So we know that with an absolute value, this means x minus 7 is equal to, wait a minute, what am I doing? So from this step, we can say that x minus 7 minus 1 is equal to 0, which implies that x is basically equal to 8, isn't it? Or minus into x minus 7 minus 1 is equal to 0, and this means minus x plus 7 minus 1 is equal to 0, and therefore it tells us that x here is 6. Okay, so please know how to solve for intercepts with absolute values. So we know that we've got 6 and 7 here. So if we say this is 6, and then this is going to be 7, and that's going to be 8. Alright, so we know that our minimum value is at minus 1. So our graph does this and that. Alright, so of course this, guys, is a side calculation, so take care not to include it in the solutions per se. This is a side calculation. It's in the rough work. Okay, so that's what we have, guys. Now the question is, when is it equal to 0 and when is it less than 0? So we know that essentially it is equal to 0 here, and we move in that direction for our solutions. Okay, maybe that's not quite visible. So it is 0 here and there. But now, when is it less than 0 in between? Are those zeros included? Definitely. Okay, so how do we write the solution here? We therefore write, that x must be less than or equal to 8, greater than or equal to 6. Alright, so what else do we know? We know that x is an element of all real numbers. Now our answer is complete. Okay, so it's not a very difficult question, to be honest. It's one that just demands one to be precise, essentially. So obviously, folks, we will get our mark, 2 marks usually for that notation. Right, and a mark for the sketch that we used to determine our answers, because those intercepts become very important. We can write the 7 here, but we don't really need it, do we? Yeah, and then that's 3 marks. Perhaps writing in a manner that we can graph, or we could easily mark the domain, but the domain is not really that strong. So this is how we can score these 4 marks, okay? Easy. So please, I don't know why this was taken out of the syllabus, because I still believe absolute value functions or absolute values are themselves important, okay? Not a problem. So how else could one solve this problem in case the graphing becomes an issue if you don't recognize the format Well, what we do, we say, well, the absolute value of x minus 7 less than or equal to 1 is going to say, we still copy this, and what do? The gymnastic of choice, we square both sides. Okay, now when we square this, remember, even if it was negative or positive, it's just going to be essentially the square of this business right here. So this is nothing but x minus 7 all squared less than or equal to 1. So what do we have here? X squared minus 14x plus 49 less than or equal to 1 also implies x squared minus 14x. This is going to be plus 48 less than or equal to 0 when we transpose. Now we have a just proper inequality that we can factorize the way we know how. Okay, it's going to be x factors of 48 that can give us 14. They are both negative, so it's going to be minus 8 and minus 6. Nice and easy. And now, once we have this, what do we see? What do we know? We know that our polynomial is a parabola. So, this is a smiling parabola, so not a big deal. So let's do it here. Origin. Okay, so our parabola is doing stuff like this. Okay. So there it is. And I just like to try and make it as proper as possible. The y-intercept would be 48, 6 and 8 are the x-intercepts. The minimum value here, at this point we don't really need to write it out. It's not that important. Although we could still calculate it, but there's no need. Okay, so our graph is negative in this region. All right, and of course these 2 points are also included, right? These 2 points are included. And everything in between. So easy. Therefore x must be less than 8, greater than or equal to 6, where x is an element of all real numbers. Alright guys, so this is very easy, not too complicated, but we needed to understand how to go about solving our issues here. So obviously if we were to score marks here, 3-step approach, whenever we need to factorize in this business right here, and the gymnastic itself is key. So these 4 marks could be scored like that, but some areas that can be considered is writing that in standard format, but again factorizing is more or less doing the same thing. So maybe we can forget about it, but yeah, squaring both sides was key. Anyway, so this is how question of that nature could be solved. Okay, so some of you are going to come across these in the future. So 1.1.2 says we need to deal with this quadratic in set form. So this is x plus 3 root of x minus 1 equals 1. So obviously the first step is to isolate the radical. This is not the cube root, but it's 3 times the square root of x minus 1 equals. So we can write here 1 minus x. Okay. Now, again, gymnastic of choice. When we have radicals, we need to undo them by looking at the root level itself. So it's a square root, so we do the opposite, which is squaring both sides. So 3 squared is 9 into x minus 1 equals, this is going to be 1 minus 2x plus x squared. And then we FOIL this out. This is 9x minus 9 equals, we can write this now in descending order of their exponents. Okay, so we transpose the left hand side and then rearrange. So this is going to be x squared. Don't know what I was doing here. Now minus 9 minus 2 is going to be minus 11x. Then this becomes 10. It's equal to 0. Alright, so we can see our quadratic is factorizable from just looking at it. This is x minus 10 minus 1. Okay. So, therefore x is 1 or x is 10. Now we check the solutions. We put 1 in the original, so this is 1. So 1 minus 1 is 0. Square root of 0 is 0. 0 times 3 is 0. So 1 is equal to 1. So this is good. And then we put a 10 in there. So 10 minus 1 is 9. Square root of 9 is 3. Right? Right. 3 by 3, that's 9. So 10 plus 9 is 19, and 19 is not equal to 1. So this solution gets rejected. We just strike it. Okay, good. Again, for rejecting this, we get a mark. Okay, the gymnastic gives us a mark. Every time we do a factorization, we're most likely going to score a mark. Okay, so how many marks? This is 1, 2, 3, 4. But now there's 6 marks. Okay, so maybe standard form. Sometimes I just mark, horribly. So this is 1, 2, 3, 4, 5. Where is the 6th mark now? Yeah, doch, I don't know. I can't find it. Yeah, doch, I don't know, guys. Sometimes marks, they just get given too much. I think 5 marks is fair here. I don't see the 6th mark. But if you get a hold of a marking guideline, if you're lucky, please check it out and see how these marks are distributed in this question. So let's get to 1.2. Now 1.2, we are given that x is equal to 4 over x plus 2. So we know that this is a quadratic, but it's hiding. So you can call it a rational equation. Because equations that are including fractions or so, call them rational equations. So we can say it's a rational quadratic. Right, that sounds wrong, eh? Okay. Anyway, we know that if we need to solve for x, we need to divide this by 1, and then we cross multiply, right? So we know. Okay, the first question, 1.2.1 says, determine in simplest set form the roots of the equation. Okay, that's easy. So we know that this is x over 1 is equal to 4 over x plus 2. We then cross multiply. So this implies we have x squared plus 2x equals 4. Then we write the quadratic in standard form. So x squared plus 2x minus 4 is equal to 0. And we factorize. By the way, we cannot factorize, can we? Yeah. But why is it factorizable? And yet we're supposed to do this in simplest set form. Because we can actually get this. Oh no, we can't. Yeah, it's not factorizable. Sorry. I was making a mistake. 2 and 2 will make 0, so it's not going to work. So we know that x is equal to minus b, or plus minus the square root of b squared minus 4ac. Can you see? This question is just asking that simple question in grade 11 that just says solve for x to 2 decimal places or what. But this time, it's not so clear what you're dealing with. Okay. So this implies that x is going to be equal to minus into 2 plus or minus 2 squared minus 4 into 1 into minus 4. All divided by 2 into 1. We can say therefore x is equal to, now this is going to be just minus 2 plus the square root. We sort out this radical. This is 4, right? And this is going to be 16. 16 minus 4 is 14, right? Not minus, but plus 4, that's 20. So this is 20 over 2, or x is equal to minus 2 minus square root of 20 all over 2. Alright, so maybe let's not conclude just yet, because we need to simplify this further. So it means our x is equal to minus 2 plus square root of 20 is 2 root 5 all over 2. Or x is going to be minus 2 root 5 over 2. Now 2 can divide both the two terms in the numerator, so x is going to be minus 1 plus the square root of 5, or x is going to be minus 1 minus the square root of 5. Now these are in the simplest set format. Okay, so there's a lot of work here. It looks a bit easy when you look at the expression, but it demands a bit more. So again, guys, you got a chance to deal with some equations involving fractions, and it turns out to be a quadratic. So let's see. Of course, we will get marks here and there, correct substitutions into the formula. Good. And essentially writing our equation in standard form. That's how we score those 4 marks. All right, good. Now let's get to it says so this says we need to calculate the product of the roots. So this is good. So we can write it here, 1.2.2. We know that. So the product of roots is going to be equal to -1 plus the square root of 5 into -1 minus the square root of 5. This is more like difference of 2 squares, isn't it? Okay, -1 is an issue. No, it's not. So -1 times -1 is 1. And then -1 times this is going to be plus square root of 5. And then this is going to be minus square root of 5. And then this is going to be -5. Okay. So this is out. So these ones take care of each other. So 1 minus 5 is -4. Very easy, okay. Yeah, I should have known that. We just square this. It's going to be 1 minus this. So this one is always going to disappear. But sometimes when you get a bit sketchy in your things, just go the long way. It's not that complicated. It's arithmetic, okay? So this is good, guys. So you can even put it in the calculator just to double check it. So it's -1 plus root 5 into -1 minus root 5. We get -4. So there's no questions about it. So of course, setting up this equation and then the answer is 2 marks, okay? So let's get to 1.3. 1.3, we are given p into x squared minus x plus 1 is equal to 3x squared, okay? Good. So we still see a parabola where we're actually increasing the gradients or decreasing the gradients depending on the value of p on this left hand side. And this is equal to yet another parabola. So this is 2 parabolas with 2 points of intersection, okay? This one is shifted. It has 2 roots perhaps. This one is the standard, so it has roots at the origin. So always think about it. What would be the effect of p here? P, if it is negative, the coefficient of x squared becomes negative. So it's a grumpy face parabola. Again, depending on the value of p, this may change those gradients to be more steep or less steep. If p, for example, is a fraction, it becomes less steep, sort of like a very wide on the x-axis graph. But if p is quite a big number, whether negative or positive, the graph becomes very narrow, okay? Think about these things, folks. Very important. And this one is also an appreciably narrow parabola because of this 3 here. Okay, all right. Now, the question comes and says we need to calculate the values of p. Do you see values of p for which the roots of the equation are real and unequal? Now, this is the question on nature of roots. But you can see there's quite a lot of marks because we still need to simplify this expression. Remember, algebra is all simplification. So let's go for it. So this implies we distribute the p inside. It's going to be px squared minus px plus p is equal to 3x squared. Now these are like terms. We can take this to the other side and rearrange. So we're going to have 3x squared minus px squared. This becomes positive px. This becomes minus p. Now, we can see that we can actually group these because these are like terms. They have the highest common factor, which is essentially x squared. So we can take out the x squared. So this is 3 minus p times x squared plus px minus p equal to 0. So we always write our quadratic in standard format. And of course, the standard format is the descending order of the powers. So this one is of the second degree, first degree, and it's a constant. Okay, we are good. So what is the question now? Real and unequal. So we can say here for real and unequal roots, it is such that the discriminant must be greater than 0. Right? That's all. So this implies that b squared minus 4ac must be greater than 0. So b is the coefficient of x. So we are going to write p minus 4. A is the coefficient of x squared. So this is 3 minus p into c is the constant. So that is what we're going to do, greater than 0. Okay, but to try and make this look nice, because sometimes when things drift, they don't look so nice, you know. It makes work a little bit easier to read when everything is aligned. Of course, I was taught that you should almost draw a vertical line through the equal signs. Same thing with these, okay, when we're dealing with equations. So think about that. Of course, to drift, it's easy, but try not to if you can. So this also implies that p squared, now this is minus 3p times minus 4, so it becomes 12p. Right, and then minus times minus is plus, p squared times minus 4, so this is going to be minus 4p squared greater than 0. So we've got like terms. So minus 4p plus p, it's going to be minus 3p squared plus 12p greater than 0. Of course, this is now a quadratic, so we can factorize it, taking out the highest common factor here, which is easily minus 3p. We can do that, or we can just take p out. It really is up to us. So if we take p out, we remain with minus 3p plus 12 greater than 0. We could easily take the highest common factor. It's not a big deal. Now, we can see that this gives us a quadratic, and one quick way to do this is a graph. But now this is a grumpy face parabola, so we need to be smart about it, and it passes through the origin. But now, what is this function here? It's delta. Okay, you can write it like that. And then what's the variable now of our delta is in terms of p. So be comfortable, guys, doing these kinds of things. And there's our origin there. So we will see that p is either 0 or p is going to be essentially 4, because 12 divided by 3 is 4. So we have 4 here. Okay, maybe let's just draw the graph first. So the graph is something like so. Okay. All right. Okay, so basically we see that this is 4 right here. Nice and easy. And we are saying our discriminant function in terms of p must be greater than 0. And we see it between these two values. It's over here. It's greater than 0 over there. Hey, my lines are just choosing to slant, guys. No matter what I'm doing. Anyway, so that is essentially what is greater than 0, because we know that these are not included, right? Not included, but everything else in between, those p values in between should be giving us a positive discriminant function. So maybe you can even write here delta in terms of p, say delta at p or whatever, guys. There's so many ways of doing things. Anyway, so our conclusion, guys, is this, that p must be less than 4 but greater than 0. Right. Now p, what is it? Is it an element of real numbers? Yes, it is. P is an element of real numbers because it can take any value, unfortunately. But now, do we really want to get into that? Because what if it's integers? Or what if it's whole numbers? We don't know, because a constant can be anything except just real. But even x can be anything, But at least we know that in different sections of maths we can tell what x should be by studying those expressions. So I think here it's safe to not qualify what p is. We don't care whether it's real numbers, integers, or what. We really don't care because nobody said anything. But if it gives us a quadratic like that, it should be real numbers, isn't it? Because the standard format of the expression it gives us can give us a clue what p should be. Could be real numbers, which would include all numbers that we know. So don't write it, guys. You can write here p is an element of all real numbers, because we could see if we did a Cartesian plane here, we did it. But again, it will depend on the examiner as to what they chose. If the variable is not x and y, we cannot assume real numbers. So don't do it. Now, folks, this is very important. Number one, what is key is to get the equation in standard format. Interpret the requirement of our discriminant. And essentially substitution is key, and getting our discriminant function. How many marks here? 8, okay? 1, 2, 3, 4. And every time we factorize, we get a mark. 5. And 6 and 7, and of course we can mark here our instrument of praise. So of course guys, here the examiners decided to be very friendly, but remember, because they understand that some questions are too demanding, so it's safe to reward an attempt so that we don't get an embarrassing situation where students just fail dismally. All right, so again guys, you can see the skills here are not really foreign to you. You know all of these things, you've been doing them, and you cannot cry about it. So this was 1.3. okay, so we're doing 1.3.2. It says now hence determine the integral values of p for which the equation has irrational roots. Okay, now this is a higher grade question purely because it's not so straightforward. This is a typical higher grade question. I mean, this is a higher grade question paper, and you can see almost everything we were doing here was indirect. So maybe it's not nice to say higher grade, but perhaps say of the higher grade questions, we can give it an asterisk to say it's a little bit sillier than, you know, the standard higher grade material. Because higher grade material is just indirect questions usually. And indirect in the sense that a lot of things are twisted, heavily twisted. You have to find your way back. And now, how are we going to deal with this? Now, integral values of p. For me, once I see this, I think of the word integers, okay? But I don't think it means that per se. But the easiest, I mean, we can't choose these other values because, I mean, think about it. Here, it's going to be very difficult to use, say, real numbers. So once they say integral, I'll think integers because we often test integers here. But now here's the thing. We need to think about it nicely. My brain is working a bit faster now. I think I did not do a good job here, did I? I'm trying to think, but yeah, I don't think I did a bad job, did I? It doesn't look like it. I think this is correct, guys. Yeah, actually, I was thinking of something now, which I see doesn't really matter. Dividing by -3 here still doesn't change what we have, no matter what. Okay, so now, guys, here's the trick. What values of p must we choose? So this is the question that needs you to know where to look. And why do you look there? Why not everywhere? Why? Why must you look where you are going to look? Okay? Key here is the why part. Okay, now let's have a look, folks. What did we say? We said this is our discriminant function. Now, first of all, the discriminant, for us to have irrational roots, it means those roots must be real as well. So you see, there's a lot of things to know. We know that the roots, once they are irrational, they are also real. Because we can't have non-real roots and we can say those roots are rational. Now, if we look on our graph, we'll see that the discriminant is positive between 4 and 0. And of course, excluding the zeros, because when the discriminant function is equal to 0, we say the roots are equal. But the question is, does equal roots mean they are also rational? Of course, if the discriminant is equal to 0, it means the roots are not just equal, they are also rational, because we know that once delta is equal to 0, the roots are first real, they are rational, and they are what? Equal as well. So this is the parameter that we get from the discriminant being equal to 0. So this means we cannot use 0 and 4 because our discriminant here is basically rational, and yet we are saying the roots must be irrational. But we understand that the roots have to be real, meaning they have to exist. And for the roots to exist, we know that for real roots, the discriminant must be greater than 0. Okay? And where is that discriminant greater than 0? Right here. Can you see there? Right there, our discriminant is greater than 0. This means we need to check values in here. But now, irrational roots. So now when we say the roots are irrational, we always write this thing like that. What does this mean? It means the discriminant is not equal to some perfect square. I'm just going to use x, but maybe let's put a and say it's some perfect. It must not be a perfect square. As much as the discriminant has to be greater than 0, because it's still a real root, but we know that this has to be greater than 0. As much as it is greater than 0, it must not be a perfect square. So now this already tells you and I that we need to check integers here. So we know that essentially for irrational roots, it is such that delta is not a perfect square. Of course, if you like, you can just write that discriminant is not equal to some perfect square, depending on what a is. And of course, you can even write a as an element of all real numbers, to be honest. Because a perfect square can come from anything. Right. But we need to see that it's a perfect square. Guys, be very comfortable writing mathematical expressions fully. Not a perfect square such that delta is not equal to a squared, where a is an element of all real numbers. Nice and easy. So essentially, guys, this is key. So now this means we need to check values in this bracket, because this is the only area where the discriminant is real. It's greater than 0. And the irrational state, we just want something that is going to give us irrational values, meaning it should not be a perfect square. So what do we know? Okay, we can say, well, we can simply say, essentially, number one, should I say Roman figure 1? Let's say we know that discriminant is equal to minus 3p squared plus 12p. Now, for p equals 1, why are we choosing 1? Because 1 is in between 0 and 4. And when I say integral, I'm going to choose integers because it's easy to check integers. Other things can be horrible. It will be such that discriminant, my discriminant is crazy. The discriminant is going to be equal to 3 into 1 squared plus 12 into 1. What is this? So this is 12 minus 3, which is just 9. And 9 is a perfect square. So we don't want that. 32. Oh, maybe we don't even need to write this. We just write the discriminant and then we say, what happens when p is equal to 2? It will be such that the discriminant is minus 3 into 2 all squared plus 12 into 1. Now this is 4 times 3. Oh, I forgot now. What am I doing? This is, because I'm seeing a cancellation now. This is 4 by 3, which is minus 12. Minus 12 plus 24 is 12. So this is good because this is not a perfect square. Let's check the last one. P equals 3 is going to tell us that discriminant is equal to minus 3 into 3 squared plus 12 into 3. What does it give us? Now this is 9 by 3, that's minus 27. And then this is 36. So 36 minus 27 is 9. Again. Huh? Am I right? Yeah. 36 minus 27 is 9. So 9 is a perfect square. So nope. It's not working. And remember, we cannot choose 4. We cannot choose values beyond 4. Why not? Because the discriminant is negative. And when the discriminant function is negative, the roots are non-real. And we saw that the roots have to be real. Because they must be real for them to be irrational. Okay? So what can we say, folks, here? So our final argument is going to say, okay, all right, okay. I will tell you this was slanted nango if no one embarrass in Pelagag. So we can say, therefore, we know that P must be equal to 2. So you can understand why this question was technical in nature. There was no way of knowing what to do here. Besides knowing the solution to the above question first, and from that solution, understanding, can you see the utility of the graph? It already gives you things that are going to make you understand exactly what you're dealing with. Easily. Of course, it's not to say if you choose other methods, because, I could have used the table. The table would give me this constraint, right? But can you see now, with the table, I wouldn't be so, okay, you could still. Because remember, on the table, in fact, the table is good in that we would know why we're not choosing values greater than 4, because the whole thing would be negative, the product. And values less than 0 would also give a negative product. So this is cool. Even a number line, okay, all right. It would still give you that piece of information. But the graph makes it so easy to see. This is why skills like that cannot be, taken for granted. So, yebo. Now, don't ask me why you should not choose 4. Why are we not choosing 4? It's because it gives us 0. And if the discriminant is equal to 0, what do we know? The roots are going to be real for sure. They will also be rational. Do you understand? They will be rational. Because we know that for rational roots, the discriminant must be greater than or equal to 0. That's for rational roots. So be very careful. Easy to get lost here because 0 is a perfect square. Did you know that? You didn't. Okay, maybe you did. 0 is a perfect square. So don't take it for granted. Because the square root of 0 is 0. So that means it's 0 squared, 0 cubed, whatever. 0 is a perfect square, essentially. So it's a perfect everything, by the way, but in this case, it also fits the description of a perfect square. Hence, we say the roots are going to be rational. So please, guys, understand the nature of roots, not just in J for just seeing what is on the book and not get what it means. Get the message behind the messenger. Or should we say, get the message being sent by the messenger. At the same time, understand its implication. Why was it necessary to send this message? This is why I tell you folks time and again that after solving a problem, don't just be happy you got the solutions. You go check the solutions at the back of the textbook and voila, this is good. Look back at it. What does it mean? What notes can you make without being prompted by someone? What notes can you make about this? Because you see a question like this is why it's a higher grade question. It's because if you think about it, you would have to understand the interval in which to look. Now this is a very nice 8 because it gives you an understanding. And then of course adjusting the axis here also helps with clearly understanding what you are dealing with. And eventually you realize that this is not a perfect square. So when this is not the case, it fits exactly the description of how the discriminant should be. And hence we choose that value of 2. Alright guys. So let's not sit on this. In fact, this thing I always say in the February-March exams, remember we did our supplementary exams in February-March, and technically the SUP was something that was decided for you by the Department of Education back at the time. You never just chose to write. If they saw that the only thing you failed so that you could pass was maths, they would give you a SUP. For maths only. You would only repeat the subject you failed. That could actually give you a pass. Because remember, if you are doing maths, if you failed maths, it doesn't matter how well you passed the rest. You could score 100% in every other subject. If you failed maths, you failed a year. So to pass, you would have to pass maths. Now, what used to happen, you would get a supplementary exam coming up in February, March. And that was decided for you. You would then accept it if you want, or you just want to sit with your fail, because you could not repeat matric either. There were no second chance programs. But I think by that time, there was this second chance program, so to speak. But it was, I don't know how it worked, because as I said to you, I once taught a group of matriculants who were doing their sort of second chance stuff, trying to get a better maths mark or physical science mark or biology mark or so. So I just didn't know how it worked, because I think it was introduced around 2006, or was it 2007? I'm not too sure, but there was something in Medunsa running there. Although we knew in general that you couldn't repeat matric, and if you wrote the SUP and that was it for you. If your marks were bad, they were bad for life. So, yani, nidla ma-cry nice la. Nipasa nje lula. Ninikwe distinctions for not sweating, guys. This is so wrong. Ugh, man. Let's not be jealous, eh? Let's not be jealous. It's your time to eat ma-cry nice. As you could see, guys, I mean, you would not get these kinds of questions in class, believe me. Questions were not asked like this in class, in general. Of course, the standard questions would be absolute value inequalities, quadratics in set form. I mean, this is also not far-fetched. These would be perhaps the questions I would say you could find in the textbook. Easy questions. But questions would not necessarily be asked like this, They would not. I cannot even mention this 1.3.2. This is like a stretch. And now these are the questions that would kind of slow you down in the exam, despite a whole lot of other standard questions. But these ones would slow you down. Okay, let's get to 1.7. Again, you would hardly get questions in this format, even in textbooks for that matter. So, and we had no access to past exam question papers. I have not seen this question paper before. Now that I have it, this is why I'm doing it for you. So we had no access to these question papers. Yes, our teachers did have access to some question papers. So if you got lucky, your teacher would give you some past exam question paper to test you in the exams. But usually they kept these to give us indirectly, like say term 1 exams, term 2 and term 3. Okay, maybe term 3, not necessarily, because those came from the district. But again, they used some of the questions in the past exam question papers, but you never knew where it came from. You had never seen it before you see it. And in the finals, not a single question that has been asked in any previous exam was to be included there. So even if you had any chance of seeing these through your trial papers or whatever your teachers had, you would always see a new question entirely. Whether standard or a little bit challenging, it would be the case. Anyway, guys, let's continue. We are doing great. So we are given that A is equal to the square root of 7 plus x all divided by x minus 2. Now it says determine the x values for which A is real. So what do you know about real roots? Real roots means the discriminant must be greater than or equal to 0. Why did I ignore the equal part here? Because the equal part only gives me a situation where the roots are actually equal. But now in this case, when it says real, it does not discriminate equal roots versus unequal roots. So again, these are some of the questions. You need to understand exactly the nature of the roots. This is why these questions were not such a common finding. Now, folks, what do we know? First of all, the word real, when given a situation like this, it means what is inside the square root must be greater than 0. That, because with a radical, you cannot have a radical of minus x. This is wrong. Or not necessarily minus x, but let's say minus 2. This is wrong because it's imaginary. It's imaginary. So imaginary stuff is not real. It's what you think about. It's what you can create in your brain, but it has no existence of any form. So it helps to understand what is given, guys. So, siyabangena. Now, we know that for A to be real, it is such that 7 plus x over x minus 2 must be greater than or equal to 0, because even if this is equal to 0, it's all good. Even if it's greater than 0, it's all good because it's going to be real. But now the question says, if this is 0, do we really have A as a function? It means A is 0 too. So can it be 0 or should it just be greater than 0? Now this is where you just wonder what you need to do, but let's just continue. We do not have a problem. Now remember, with this you cannot say this is over 1 and then cross multiply. This is forbidden. You can't do that. Why? Because you cannot tell the sign here. The sign is both positive or negative, depending on the x value. So if the sign cannot be clearly determined, you cannot cross multiply or divide throughout by something you cannot decide its sign. This is why with inequalities we isolate 0 and we deal with the expression as we see it. So here don't do it, because if you do it, you'll get a partial answer, meaning one correct portion, but the rest is going to be missing. So once you don't know or you cannot determine the sign of what you have, you cannot cross multiply with that, because cross multiplying by a particular sign affects the inequality. Now you cannot do that, so please don't do it. So no cross multiplication here. Once 0 is isolated, that's a good thing. It's a goal. All right? Right. Now, what do? We are going to take this into a table. So you see, sometimes certain things are just so wonderful. You just do the things. That's why I teach you all these things, so that no problem becomes, because certain ways of solving this, I've seen some teachers teach an absolutely wrong thing, but it works because it's a coincidence, not because it will always work. It's just a coincidence. So be very careful of coincidental solutions. So we take the numerator, we equate to 0, we solve for x, we get -7. Take the denominator, we equate to 0, and we solve for x, we get 2. So this is what we do. Okay. Now, when is this binomial factor going to be 0? When x is equal to -7. When we put a value greater than -7 but less than 2, let's put 0 out of convenience. This becomes positive, and it will always be the case for values between -7 and 2. What happens when the value is actually 2? Well, it's going to be +9. We just focus on the signs here. When we put a greater than, it's always going to be positive. Of course, this is a linear expression. So obviously, if we've got a 0 in positives, that should be negative. See, second nature. But you can check if you don't trust it. Let's say this is 7 minus 8. Can you see it's going to be -1? So that's it. We come to the next one. When will this binomial be 0? When x is 2. The zeros are very important, guys. When you put a value greater than 2, that binomial becomes positive, and obviously it should be negative all over. But we can check it. Let's put 0 in there, we get a -2. And it will be the case for any value between these two values, and at that value and below that value. So that's it. Now we're doing a division. So negative divided by negative is positive. 0 divided by any number is 0. Positive divided by negative is negative. Any number divided by 0 is undefined. You write UD. Positive divided by positive is positive. Now our solutions are going to anchor around our critical values. But now, here's the thing. Is 0 included? Yes, it is. Is 2 included? No, it is not. But we want positive, so we go in that direction, or we go in that direction. So we write our solution. Therefore, our x can be less than or equal to -7, or x must be greater than 2, where x is an element of all real numbers. Of course, this would have been a restriction. Why? Because a division by 0 is undefined. And you see, the table gives it to you nicely. Now, the table here is better than the graphical method, okay? Because the graphical method, you'll have to understand how to interpret graphs to be able to appreciate this, because it doesn't mean it's not applicable, but you need to understand. So on a Cartesian plane, so Now let's solve for x here. I mean, the y-intercept is 7. So it's over there. And then this one is going to be minus 7. Let's say it's over there. So if we join these 2 points, we are sorted. So this is the first graph. Right, so we have minus 7 and 7. The second graph is doing this at 2. Maybe let's say this is 2 and the x is going to be 2 as well. The x-intercept. So this is going to be the story. I don't know what this is doing. It's going to take away, man. Get it on my tie. Alright, so can you see these two graphs are like this? This is essentially... No, man, what am I doing, guys? Yo, wrong graph. No wonder it was giving me troubles. It was giving me troubles because I'm doing the wrong thing. So this must be minus 2 over here. Let's say this is minus 2. And what would be the x? It's going to be 2. Sorry. So, can you see the graph? Sometimes if you're not comfortable with graphs, they will humble you. Okay, so we've got these two graphs, these two straight line graphs. Now, you see with graphs, you won't really see so nicely what you are dealing with, because the question is we're doing a fraction. So that means we're saying the graph on top divided by the graph below. So the y values of the graph on top, because once you represent this in terms of x, that means y as a function of x. Now, you could see that technically, when we divide the y value here, where x is 0 for the other, no, slanted, you will appreciate that this y value here for this other function divided by the y value of this function, this becomes undefined. So this is that part. Okay? But 0 divided by any other value here is actually defined, because 0 divided by any number would be 0, and 0 is included there. So these are some of the ways in which you can solve this using the graphical method, but it will challenge you if you're not careful. Okay? It will challenge you big time if you're not careful, but sometimes it's the absolution if you are comfortable with doing graphs. So again, this is grade 9 graphs. By grade 9, you're already doing these graphs. So I don't think you should have struggles figuring out what to do. If it linear inequalities are started in grade 9, I believe, so you should be comfortable with this. Now, we have sorted this, guys, so we don't want to complicate it any further. So, can you see, guys, there can be some troubles because, okay, anyway, this gives us the same solutions. We are happy. All right, so how many marks here? 5. Really? Of course, guys, writing out this expression is key, because we are interpreting that statement mathematically. Okay? Now, depending on whatever tool you have used, so this is a mark, this is a mark. So this is going to be essentially 3 marks. Of course, I would say this is the 4th mark, depending on what you used. And I would say perhaps identifying the domain here is also key, Because if we don't identify the domain of values of x here, we are really bluffing, are we not? Yes, we are. So certain questions are not so difficult, guys, but they are technical in nature, is that you have to answer fully. You can't answer partially. Because if you don't have that x is an element of real numbers, then you are gone, okay? You lose that mark. Now you can see that this is not a very difficult question when you know what to do. But it can be a very tough question for a student who's not so clear as to what am I supposed to do here? What is its effect anyway? So guys, you can get these kinds of questions in the NBT. Okay, so this question can be in the NBT, and this question can be in the NBT. Even this question you can find in the NBT, but I wouldn't really say much about that. This is more of a standard question, and it can feature anywhere. But these ones, look out in the NBT. Because you no longer really, okay, you might see them in the exams as well, but most likely in this exam, you can see questions of that nature. And the worst part is, they may just ask you this question here and give you options and leave you to sweat for that 8 marks in your head, because these can be made into very silly questions. So this is why it helps, guys, to not just sit back, but practice every material given to you. Remember, I'm not giving this to you so that you can just, go and just write answers if you get a question of this nature. No. Remember, the exam can bring something else that is actually latching onto this knowledge. You need to be able to apply this knowledge even in that question, because whatever you may need to do to unlock it into this manner, then you follow on with this way of doing things. So this is not how the questions are going to come. Of course, if you are lucky, you can get the same question, but you're not always going to get the same question. Okay. All right. Okay, guys, let's just go on. Maybe this question too is a good question for algebra as well, because it can feature in question 1 in your current examinations. So we're told that x plus 1 is a factor. So now this is factor theorem, or should we say remainder theorem, of the polynomial f of x equals x cubed minus ax squared plus ax plus b. And if divided by x minus a, the remainder is 4. Of course, guys, this is typical of NBT stuff as well. You could get it here most likely, or even in any exam it can come, because remember, you know this, it's there in your books. Although you may have not been asked in this manner, but it's there in your books. So the question says calculate the values of a and b, and you can see quite a lot of marks, but again, not because it's too difficult, but it's just asking you questions that when you were taught this section, did you understand it? And understanding it doesn't mean you just heard what was being said. Can you see beyond that? Right? Right. What do we mean when we say this is a factor? It means f of 1. Sorry, not 1, but minus 1. This story is suggesting that if it is a factor, f of minus 1 is equal to 0. Did you understand these things when you were doing them in class in grade 11? Because this is grade 11 work. But it's just going to be brought to you in a very ugly and aggressive manner. Will you see it? That's the idea. When we say f of x is divided by this, what exactly is the implication here? The implication is that f of a must be equal to 4. These are the things that you need to know, because this comes from remainder theorem or factor theorem, or just simply long division, because that's how we know these kinds of things, from just long division, which you learn in standard 7 and standard 8, which is grade 9 and grade 10, but maybe mainly grade 10, long division in terms of algebraic expressions, perhaps grade 10. In grade 9, I don't think you do it using these expressions per se, unless I'm not so sure, but I'll check in your books or your study guides. But the long division is started in grade 5, which is standard 3. But it's arithmetic, it's purely just numbers. Okay? Because as you would see in your NBTs, you would be asked to solve certain things without using a calculator. That means you need to know long division from as far back as grade 5. Long multiplication kicks in at grade 7 and grade 8, perhaps grade 8 mainly, because I started to understand it better at grade 8. Yeah. But again, our education at that time was attacked anyway. So things were not as very clear as they should be. So guys, this is what we need to do. And guess what? This tells us that we're going to solve simultaneously. Can you see? Simultaneous equations. Again, can you see, guys? This is stuff you already know, but now you have to find a way of understanding the given information enough to solve the question. Anyway, so this is it, guys. This is algebra, so it's not out of question. So we know that, well, we're given f of x equals x cubed minus ax squared plus ax plus b. So we are told that x plus 1 is a factor of f, right? Such that if this is the case, it means f of minus 1 is equal to 0. Now this implies where we see x, we put minus 1, minus a into minus 1 squared plus a into minus 1 plus b equal to 0. Now just to avoid this drifting effect so that things align nicely. So this also implies, now this is just minus 1 minus a plus b equal to 0. Therefore, what can we do here? We can just decide to make b the subject so that these get out of the way. So this is going to be 2a plus 1. And we can call this one equation 1. Okay? You can say also, seeing that essentially f also, okay, let's not explain this time. F of a is equal to 4. That's the impression that gives us. So this implies what? Where we see x, we put a. And then okay, so let's move this a bit so that we don't have this drifting effect. So we just simplify here. This implies that a cubed minus a cubed plus a squared plus b is equal to 4. We can say this implies, or maybe we can say therefore, we understand that a squared plus b is equal to 4, because these ones will cancel out. We can make this equation 2. Obviously for me, I would just continue here by taking that and plugging it here. But let's just go the standard way. We say put 1 into 2. So we have a squared plus, instead of b, we put 2a plus 1 is equal to 4. This implies that a squared plus 2a minus 3 is equal to 0. Remember, this is just 1. When you distribute, the bracket is off, and then we transpose 4 back, we get this. Now we can factorize here. Can you see, guys, knowing how to factorize second nature, we are good to go. Oh, so this is minus 1 plus 3. Okay, is good. So we can see that therefore our A is minus 3 or A is 1. Okay, that's okay. Not a problem. Now what does that mean? It also means that B is going to be 2 into minus 3 plus 1, or B is going to be 2 into 1 plus 1. This is minus 6 plus 1, which is minus 5. This is just 3. And guys, remember, we need to check our answers, because now we've got a lot of answers. Are they all valid? Are they not? So remember, we need to think about the original expressions this time around. So the original expression is this one. We can check this parameter, that when we substitute these values in there, when we divide by this, are we going to get 0? Another student may decide to say, okay, is this the question? Because this is the question to check. But we need to check it in the original. Okay, so let's see, does it really work? So remember, when we check, we take the set of values. This goes with that. Okay, so let's see. We are going to have minus 1 cubed, and then we are saying A is minus 3, so minus minus is going to be plus 3, so it's going to be plus 3 into minus 1 squared. And then A is again minus 3 there, so it's going to be minus 3 into minus 1. And then B is minus 5. Indeed, we get 0. So this means this checks out. You can do the same for those values. I'm not going to waste time. So if that works, usually this works because we didn't square anything. We just derived those equations. But again, we can check. Let's not be lazy, just in case. Because remember, in the exam, this is survival or you die. Now let's go back and say, fine. We say A is 1 and B is 3. And again, we're going to check f of minus 1. So we have minus 1 cubed. And then minus 1 into x, so this is just minus into minus 1 squared. Okay, this is plus, because A is just plus 1. So this is going to be plus into x, which is minus 1. B here is 3. We just say plus 3. Again, we get 0. So it proves that this set also satisfies that constraint. Nice and easy. Obviously, folks, if we satisfy the first equation, we most likely are going to satisfy the second equation too. But hey, when you have time, you can check the other one. But this first check, if it works, then it talks sense, because this was also important. So we don't really need the second one per se, but you can check in case it's not the case. But I suppose it should be the case. Send your name again, but let's try. Now, folks, we know that A here is minus 3, right? And we are also suggesting that A in that expression is also minus 3. So we're going to substitute minus 3 when A is minus 3 in that expression. Let's see if the remainder is 4. So we're going to put minus 3 cubed for x, right? a here is minus into minus, so that's going to be plus 3 into a, which is minus 3, that would be squared. Then a is minus 3 again, we've got minus 3 into x, which is also minus 3. Then we're saying b is minus 5. I get 4, so this checks out. And then again, let's check when a is 1. So this is going to be minus into 1 this time. So be very careful. This check can be quite a tedious process, folks. And then here is going to be plus into 1. And then b is 3. So I get 4. So it means all of these values work out either way. Okay, so you move on knowing that these 11 marks are in the bag. You understand? They are in the bag. So obviously, folks, I would say this is key. Getting this equation is key, but I do believe that should also be marked, because first, this is the defining equation according to the statement given. Then this is for correct substitutions and deriving an equation. So 3 marks is cool there. But since we're doing a similar thing here, I think we can just get a mark for this defining equation, but for substitutions, not necessarily. But for that equation is key. Now, whenever we put one into the other correctly, we get a mark again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because factorization is part of the 3-step approach. And whenever we use those key areas, step 1, step 2, and step 3, we often score a mark. So guys, this is algebra for the Bozzas. Okay, let's do 2.2. Now 2.2 says the polynomial p of x is equal to 5x cubed minus x plus k. Can be expressed in this form. Of course, what is it? This is what we are dividing by. So this is the divisor. That is the divisor. This is the divisor. Okay? What we divide by. Now, what is this guy? This guy is the quotient. This is what we get when we divide by the divisor. So we call it the quotient. Okay? And essentially, we know that 7 is the remainder. This is what remains. Okay? So this means when we divide into this expression by this, this is the remainder, because the quotient is almost not going to help us much. Why? Because we know that therefore it just means p of minus 2 is going to be 7. This is the ultimate situation. Why is it so? Because when you put a minus 2 in there, this is minus 2 plus 2, this is 0. 0 multiplied by whatever that quotient is going to be 0. And guess what? We remain with 7. So again, this is one of those questions that sometimes may cause you pain if you don't understand mathematical expressions in different formats. And so you will end up crying. So essentially, guys, which says, what do we know? P of x is this one. And also, we understood that P of x is written as x plus 2 times q of x, which we know is going to be quadratic at times, but it can be linear also. Since this is a cubic, this should be quadratic, right? Plus 7 implies that P of minus 2 is equal to 7. This we understand that if we say minus 2 there, that's 0, 0 multiplied by anything is 0, so 7 remains, so that's the remainder. So this implies, now we take this back because the question we want the value of k. So it means 5 into minus 2 cubed minus into minus 2, plus k is equal to 7. Let's move here so that we don't drift too much. Okay, so easy now. This is 8 by 5, that's 40, minus 2 plus 2, plus k is 7. So this is 42 with transpose. This implies that k is going to be equal to 7 minus 42 is minus 35. Nice and easy. So this is good, guys. This is good. And you can check the solutions. Now we go back and say 5 into, we substitute minus 2, and then this is cubed, minus into, x is minus 2 again, and then k, we just write minus 35. What do we get? Minus, why am I getting minus? Oops. Okay, there's a mistake, folks. Remember, negative, this is gonna be minus 40. What are you doing to me? Okay, you see, checking, guys, may look very strange because I'm getting minus 73. So it already tells me if I'm not getting 7, there's something wrong. You understand? So this is basically minus 38. Okay, so 38 plus 7 is 45. Okay, so we're getting 45 here now. Now let's check again. 5 into minus 2 cubed minus into minus 2. And then we add 45. Guess what? I'm getting 7. So now I know this solution is good. So folks, checking your solutions, making a habit, because you can do a whole lot of correct things. Just one small mistake will horribly affect your answer and you lose a very crucial mark. So folks, what does this mean? It means we needed to understand this, and then the actual substitution and the final answer. This is how we score these 3 marks. And of course, guys, that's it for question 2. A proper 14 mark, which is not difficult. Once math is settled in your brain, here, what was the total? The total here was 33 marks. Fat 33 marks, nice and tasty. So guys, we're gonna deal with functions next. I will do these functions separately. Look at that, we did absolute value functions. Okay guys, you can cry about it, you may not, but see, now here's the other portion of algebra that can pop in. Of course, with algebra in your current curriculum, you don't really get all of these questions. They may just pop one of each. Any one of these questions can be found in your question 1. So any one of these. Can be in question 1, in paper 1, okay? So that you need to know, guys. Aw, ayisafuni. Yewena sikhathi lomphaphela. Imphaphela kaniti. Oh, Nkosi yami. Oh, Nkosi yami. So any one of these questions, guys, can show up in question 1. Now let's do this question 4 so that we can say our 2 hours have been spent well. So 4.1 is, we are given that the log of m minus the log of n is equal to the log of m over n. Now we are to prove the law. Okay, so hey, dilibele kanti neyenzwa kanjani, guys? Do we make this x maybe and then convert to exponential? Let's try. So we're going to say let log m over n equal to x. This implies that m over n is going to be 10 to the exponent x, right? Because when the base is not written, it means it's 10. But then do we proceed here? So this is 10 over 1. This implies that m is equal to, cross multiply, we will get n times 10 to the x. It's not taking me anywhere, is it? Let's take this to the other side. M minus n times 10 to the x is equal to 0. Lord, is it helping? I'm trying to think, guys, what is cooking here? Yeah, but I can't go back to logs again, can I? It's not gonna help me. Okay, dilibele, guys, the proof, yes. But we used to name something, but again, gobi maths sane wa grade 12 ndiyayazi noba ningathini ndizawubuya nayo awuthi size ngelinye iqhinga. Remember kwi-theorems ne, sometimes siyakwazi ukuprova i-theorem ngokusebenzisa ezinye. Now masike siqale siyicinge ke ngokusithi, well, let's just accept something. Sometimes you used to have to do this and say log of m times, okay, maybe let's not use, accept that log of x times y is equal to the log of x plus the log of y. And we also need to accept that log of a to the exponent b is equal to b times the log of a. I'm just going to use these laws. I'm just saying this so that someone understands what I'm going to do next. Because now I'm stuck. You know what, when I get stuck, guys, I used to do this. I don't know if it is acceptable or not. Remember, guys, I am not sure about this one. Because the libelele proof, that was 2005, guys. Imagine. That's how many years ago? That is going to be exactly 20 years ago. Alright, guys. And that's for this bulal. I'd never prepare for these things. Now ziyanibonakalis bandidom eh? Seziyanchaza bandidom kakhulu. Ndingujam girl, inhloko yegusha. Yes, sis man. Yes, sis man. Hey, kodwa njengayo inhloko yegusha ndiyanqaba ke son. Ngoba liqhekeza khakhayo. Okay. Hey guys, I'm a bit stuck now. So we can say, well, then we know that log of m minus log of n is equal to Now let's see. What is this? This is the same as log of n plus into minus the log of n. Is it going to work? We will see. So this is log of m plus, we can take the exponent back. This is the same as log of n to the minus 1. This is the same as log of m plus log. We don't write negative exponents, so this is 1 over n. Right. Now using this law, this is going to be the same as log of m times 1 over n, which is log of m over n. Siyigqibile. Gqibiyani, but ke ngoku umbuzo uthi ingaba lento yamkelekile na? Hey, andazi nam guys, kusala isebenzile. Isipadile. Hey, hayi nabakazi. Hey. But ke xa uyendlalela into guys, you normally get marks. So in my opinion, for writing these laws, ndingathi thatha imark mntana esikolo. That's if this is acceptable. I don't know guys. Sometimes, you know what, I mean, ndi-fraud nje kwamna nje. Ndiyakwazi uyinyokonyela into ingene la ingafuna ungena khona. And now, technically guys, using a law, remember the three-step approach? Whenever we use a particular law to sort things out, remember we used a law here, that should be a mark. And then this is not necessarily a law, but it's more of a simplification. And essentially when we use a law again, we get a mark. And essentially contracting this whole thing back into this. Yes, it may have been the answer, but okay, maybe it's too obvious. Maybe we can mark here, changing this into a positive exponent. Can you see the 4 marks can still be scored here? All right. But this looks like forgery, you know. Ingathi sinyokonyele kakhulu guys. So angisazi namangati kwathinyalo. Sekumele kwentekeni. Hayi. Sengixakekile phela nami manje. Kimarket. Hey, yeah. Okay guys, so this is what you would do sometimes. Use other laws, because remember, you are asked to prove this one. It doesn't mean the other laws are invalid, but I suppose because nobody knows about them, we assume at this stage we will write those laws and say we accept that those laws are true. Then we can show that this is indeed the case. But let me try something guys. You know, we used to do something here. Let's not name this one x because Bonilia failure. Let's name these two something. I think we used to do that. We're going to say here, let log of m equal to, say, x. Ne? This implies that we can say and log okay, masenze kanje and masibhale la, and log n equal to y, for example. And then this implies that m is equal to 10 to the exponent x, right? Because when this thing is not written, this is what it is. And n is going to be 10 to the exponent y. Right. So this, we can say then, we're looking at this expression that essentially m over n is nothing but 10 to the x divided by 10 to the y. Okay, which would also imply okay, we're simplifying this now. Same basis, the exponent subtract, so this is 10 to the x minus y. Now we want to go back to the situation now. Ngiyazibuza ngiyaziphendula kodwa ukuthi ngizoyiphendula kanjani mani lanto. Ndiyiphendula kanjani mani lanto? Ngoba ngoku ingathi ifuna ukundiqhela. Ibatla ho ntlwaela. Because normally we start doing things like this, mos. We don't really start on this side, do we? But does it really matter? I don't think so. So what does this mean, guys? This implies that m over n. And as guys, sometimes because we've got this situation. Now remember, guys, with this situation, when we introduce logs, guess what happens? We can say therefore log of m over n is equal to log of 10 to the exponent x minus y, right? Which is going to be equal to, using that rule now, x minus y log 10, right? Now remember, when the base is not written, it means it's 10, so this is 1. So this is x minus y into 1, which is just x minus y, which is log x ngibani log m minus y ngibani log n. Yeah, ingathi yiyo ke ngoku. Ingathi yiyo ke ngoku. I'm not sure, guys, but sometimes ihamba le ndlela, so check on the internet. Sometimes you'll find this thing. I'm not so sure if my plan is panning out as well as it should, but it went something along these lines. Anyway, guys, so yeah man, so there are some things that we need to think about. You get it? I think it's something like this, but it used to not make sense anyway, this proof. All I remember is that it used to not make sense. It sounded like a fraud, just like my first attempt here. But if it works, it works, guys. What can you do? But I think it makes more sense when we use other laws to prove another law. But again, if you look at it here, we had to use a law, you know, we had to use a law of some sort. So yeah, whatever, guys. But I don't remember this thing, honestly. But let's pretend it is this way now, so we can safely say this is the case. And when we use a log law is good, and this is good, and therefore the final substitution, I suppose, is good. But again, this was volunteered. Maybe we can avoid it and say yikes, maybe substitutions, yeah, something like that. I don't know, guys, so try to get a hold of this. Probably you should find it in the government website, but I got this question paper from a non-governmental website, if I'm not mistaken. It's called South African Papers or something. I don't know if it's a government site or it's a non-governmental site, but it says South African Papers, not exam papers, but South African papers or past papers. I don't remember now, but I'll find out. I'll put the link to that website in the description so that you can go look for yourselves there, or at least get your teachers to check these solutions for you, because these kinds of things, guys, you can see that you need to be a thinker to get through them. Otherwise, if you're not, you are going to be dead by morning. Because the other question is, yikes. Yeah, man. But you see here, I was told to prove this left hand side is equal to the right hand side. Now I'm feeling like, yeah, doch, die reversile. Hey, angazi mfethu, angazi, whatever. So sithi 4.2. Yabona ngoku le nto create it out ngoku engqondweni yami iyangiphela. So this is 4.2.1. We need to simplify completely. So guys, this is anything you can come across. Log of square root 3. Remember how you read a log? It's a log of a number, right? To a particular base, not a log of a base to a number. Okay, please don't read things wrongly here. This is log of a number to a particular base. So this is base m. Okay. Okay. So learn the right things, the right terminology. Multiplied by log of m to base 9. Okay, this is what we have. So this is equal to, now folks, we can see 9 can be reduced to some 3 of some sort. Of course, there are some deductions to log rules that I will show you at some stage when I am trying to show you things. Now remember, guys, once we have the base, we know the log law that says log of a number to a particular base is the same as the log of that number to base 10 divided by log of the next number to base 10. In fact, we can even choose any base of our choice. We can choose base x, base a, but it's safer to just choose 10 here. Then we are multiplying this thing here. This is the same as log of m divided by log of 9. Okay, continue. Log of square root 3 over, oh yeah, why am I doing this? At this stage, we know that this will take care of that, right? Because when you multiply the numerators and the denominators, these are factors, they divide to 1. All right, so we have log of square root 3 divided by log 9 is basically 3 squared. And then what do we see? We will see that this is the same as log of 3 to the 1/2, right? The square root of 3 is log to the exponent 1/2 over essentially log of 3 squared. Now we use another rule. We know that this is 1/2 times the log of 3 divided by 2 times the log of 3. Again, these two will divide to 1. And when we multiply by 1, it is essentially invisible. So this gives us a quarter. Nice and easy. Okay, all right, okay. So now, guys, we can just choose a value for m. Let's say m when you want to check this solution, because remember, the original provides us a way. So we can choose any value for m. Let's choose m is 2. So we have log of square root 3 to base 2. and then we say times log of m, which is 2 now to base 9. Okay, I get a quarter. So if my calculator gives me a confirmation that if I choose any value for m and I still get this, it means my gymnastics are correct. So essentially, using a law, this is step 3. Okay, or change of base if you call it. Okay, good. And essentially this step is also key. How many marks was this? 5 marks. Are you real? Are you for real? Okay, all right, okay. So change of base, I mean, that's good. And then essentially changing these two into exponential forms, good. Using the law where we drop the exponent is good, and the answer is good. For me, this should be 4 marks. I'm finding it hard to understand where is the 5th mark. Maybe it's a reward for doing the good job. For me, this should be 4 marks. I don't see 5 marks in here. Anyway, if you see the marking guidelines for this, probably it will make sense. At this point, I don't care. I give marks according to what I see, but maybe there's something else. Yeah, okay, let's go on. So we have the square root we've got the square root of 3 to the x plus 1 minus 3 to the x minus 1, all divided by 3 to the x minus 2. And this whole shenanigan here adds 1. Okay, so this is equal to now we sort this out. This is going to be 3 to the x times 3 to the 1. We don't really need to write it, but I'm going to write it. 3 to the x times 3 to the minus 1, all divided by 3 to the x times 3 to the minus 2 plus 1 over 1. Okay, so this is equal to now we can factorize here by taking the highest common factor. 3 to the x will remain with 3 minus 1 over 3. Okay, divided by 3 to the x times. Now this is basically 1 over 9. Okay, I'm moving fast now, folks. And we know that this and that will divide to 1. Okay, maybe let's show that it's actually the entire expression, not just the 3's. Stuff like that. And then, of course, we had 1 over 1 in here. So be patient with these kinds of expressions. They tax you time, and yet they also tax you your concentration. So 3 times 3, that's 9, minus 1, that's 8 over 3. So this becomes 8 over 3. And here we're going to say this is divided by, and if we divide by this, we are simply multiplying by the reciprocal, right? So if we have 1 over 9, this becomes multiplied by 9 over 1, okay, plus 1 over 1. Okay, we see again here that 3 goes once, goes 3 times. Now, you can see where we are going. So this simplifies to just the square root of 8 times 3, that's 24, plus 1, that's just 25. Okay, nice and easy. So this is equal to 5. Now the question is it plus or minus 5? We don't care. If we're not defining anything, this is a positive square root, so we will take it as a positive answer. But if we're defining something, then we look at it and see for what it looks like. Okay, something squared, definitely plus and minus would work, but something cubed, just one answer works. So when you take an even root of something we don't know, we just consider the positive answer. Now let's see. Let's choose a value for x and say 2. Remember, every time we solve something, we can go back and use our calculator. Square root of fraction button, so we say 3 to the, now let's choose x's, say 1 for example. So this is going to be squared, so 1 plus 1, okay? 3 squared minus 3 to the 0 divided by, so this is 3 to the minus 1, and then we add 1. I get 5. So this means any value of x that I can put, but here you need to choose a value when checking the solution. And if this is good, it means our mathematical gymnastics are perfect. Okay guys, so this is cool. So obviously when we factorize in maths, we get a mark, right? How many marks this is? 4 marks, okay. Using the exponential laws here of separating these, powers into rather a product of powers is good. Be careful when I say a power, I mean the entire exponential expression. I'm not referring to the exponents. So this is 1, 2, and then of course changing this to a positive exponent, that would be the third mark, so 1, 2, 3. Okay guys, I think I have made up 4 marks somehow, but I'm not too sure how this was structured. Some expressions can be quite challenging. Okay, let's keep going. 4.3. So any one of these you can meet in the question 1 of paper 1 or in the NBT if you're going to write it. So be very comfortable. Don't look for a specific book when you practice for these exams. Everything you can come across will haunt you in that exam, okay? Don't focus on a particular exam because of particular questions that go in there. Just make sure your maths is an all-around good substrate for you to plant your seeds, and so you can get good results. Solve without using a calculator, it's common as well. 4.3.1, we've got 6 to the exponent 2x divided by 9 to the exponent x equals the cube root of 4. Okay, not a problem. So this is equal to, first thing, we don't want sets, right? So this, we can show it as a product of prime numbers. 2 times 3 to the exponent 2x over, this is 3 squared to the exponent 2x, no, exponent x, sorry. This is equal to, this is 2 squared, now a cube root is 1 over 3, like that. Okay, we're moving. So we distribute the exponent, so this is 2 to the exponent 2x times 3 to the exponent 2x divided by 3 to the exponent 2x equals 2 to the exponent 2 over 3. Easy, eh? Yeah, man. This is easy. So this and that, they just divide to 1. And guess what? We've got 2 to the exponent 2x equals 2 to the exponent 2 over 3. Same basis, the exponents are also equal. 2x is 2 over 3. Right. Therefore, our x is going to be, when we divide by 2, it multiplies the denominator to 6. 2 goes once to 6 3 times. So this is a third. Nice and easy. Again, let's check our solutions. We take the value of x and we plug it into the original, and let's see if these are going to be equal. But now this one forces us to solve the two sides separately. Okay, so we've got 6 to the exponent 2 into 1 over 3. So I like this Cashew, it's so proper. We've got 9 to the exponent a third. So let's see, what do we get there? So the left hand side gives me 1,587 to 3 decimal places. Let's see, we are going to get the same thing here. Shift cube root of 4 gives us a similar solution, 1,587 to 3 decimal places. So if the left hand side is equal to the right hand side, then I know my solution is bulletproof. So guys, you don't need to see the memorandums here. Mathematics has a way of providing you a way of making sure that what you did is correct, as long as you understand what you are doing. But if you don't understand what you're doing, of course, you won't even know what to do or how to check whether something is right or wrong, because at some point you don't know what you're doing. But now checking solutions is to ensure that if you're an A+ student, mistakes don't catch you out and rob you of your A+. Okay. But as a struggling student, again, this can help you to pass an exam, because what you can handle, you make sure you check so that you are sure it's correct as you present it. So that what you don't know, you don't even bother yourself about it. Because at the end of the day, what you know, you must score marks. What you don't know, be strategic. I'm showing you the steps and the key areas that are usually mark worthy, so that even if you don't get the solution to a particular question, but a strategy on how to get around the parts that you know and understand, you apply the laws that you know and understand, you can score marks through those steps, especially in multi-step questions where there's many marks. Because many marks means multi-steps. So you can pass if you do this. But if you are careless, take everything for granted, you will always be wondering, why am I not getting it right when I know what is cooking? It's because you are cooking amaxoxo. Upheka amaxoxo wena into iphekayo phana. Ngubani ozotya amaxoxo? Sidla amaxoxo thina. Okay, 4.3.2. Usiphakela amaqonya. Anyway, 5 to the exponent x plus 1 plus 4. Hey, please guys, abantu abatya amaqonya namaxoxo ningabi offended. Ngenditye ezo zinto guys, futhi necephe elikhe lakha ukutya okufana nokya ungakulinge nje undiphakele ngelo cephe. That's why I hate restaurants in certain areas in South Africa, because I know they cook all of these things as part of the menu. And then you order your menu, and then icephe bebekhe ngalo phaya amaxoxo namaqonya bazozokha ngalo irice yakho okanye isityu sakho. Lilonke lityile nawe ixoxo okanye iqonya. Uyibona le nto? So ingazotya izinto ezisinaks. Okay guys, masiyekeni, izawucaphukisa abantu abazityayo ezi zinto. X, 5 to the exponent x, we break it to 5 to x and 5 to exponent 1. Plus 4 equals, we change this, we never like negative exponents, so this is 5 to the exponent x. Right, and then we multiply by the common denominator. This is the CD, which is 5 to the exponent x, such that we multiply there, we're gonna get 5 to the exponent x all squared times 5. In fact, let's put the 5 as a coefficient. So this is going to be 5 times 5 to the x, but because I'm multiplying it there, it's going to be squared. Plus we multiply here, it's going to be 4 times 5 to the exponent x. Here it's just going to be 1. So this implies that we've got 5 into 5 to the x all squared plus 4 times 5 to the x minus 1 equal to 0. Now this is a quadratic, so I've shown you guys the higher order quadratics, so I'm sure this should be a walk in the park. So this is 5 times 5 to the x, this is 5 to the x. Now to get a 4, this must be positive, and there's a negative 1 there. So this is good. So this implies that we've got 5 times 5 to the x equals 1, or 5 to the x is equal to minus 1. Is it possible for any variable exponent to give us a power that is negative? The answer is a hell no. So this one we reject immediately because it doesn't make sense mathematically. Remember, in maths we almost always lean on the real number solutions, although non-real stuff is also considered, but in special cases, okay? Alright, so this implies that we've got 5 to the x is equal to 1/5 when we divide by 5, which we can change into exponents again, negative. So this is 5 to the minus 1. Same basis, therefore the exponents must also be equal. So this is very easy stuff, not complicated. Any student can score maximum marks here. This can come in question 1. Please don't be caught pens down. Now let's have a look. What is cooking here? What is cooking is this story right here. Using any laws to break things up, and perhaps to also, using the law. That's step 3 in our 3-step approach, and that's how we score marks, by the way. And then we multiply throughout, not a big deal, but the nice thing is to write the quadratic in standard form. Now whenever we factorize, we are doing magics, isn't it? And rejecting the solution in algebra is key. How many marks was this? 5, yes. 1, 2, 3, 4. And then of course 5 for the x value, provided we need to go and check that solution. So obviously x to the minus 1, that's just 5 on the right hand side. Let's see, this is minus 1 plus 1, that's 0, that's actually 1. Any base to exponent 0 is 1. So this is 1 plus 4, which is 5, it balances out. So can you see, guys, there's no excuse here for walking away not so sure what you have scored in questions of this nature. Here you just get to know what you did. Now solve for x, solve for x and check whether your solution is valid. Why is this question coming? Well, but once we are directed, we need to show the check, guys, right? We need to show the check, because if we don't show the check, then we're not answering the question. Usually the question just asks solve for x, maybe without using a calculator. To check the solution is upon you as the student, knowing that we never have a log of a negative number. So meaning the check must prove that these kinds of things here are not negative, because if they are negative, then this does not exist, it's undefined. So that's just the check. So again, understand the expressions. Understand the expressions. I know a lot of people will tell you, you're overthinking things, but hey, overthinking things means you're going to be a very safe professional who's not just going to assume things are going to work for everybody, especially if you are in fields like medicine, where someone can die, or you are an engineer, you're producing or creating planes. I mean, you can kill a number of people if your planes are faulty. So precision is key, and to be precise, You need to be obsessed. That means overthinking things to a point where you know where the limits are, and therefore you play within the safe range. Then you know, bulletproof. You get it? So be like that, guys. You can't go into fields that can affect a whole lot of things on a large scale, and you're just going through the motions. Just stay away, please. Don't go there. Go somewhere where it's safe to do so. Nobody gets hurt. You just simply follow orders. But people like me like to make the orders instead, so that's why I have to be like this. You get it? Anyhow, let's go on to this question. So we've got log of 10 minus 20x. It's not 2x. 20x minus the log of x squared plus 2. This is equal to 1. All right, so we know the law that we just proved above. Can you see we were not asked this law for mahala? So this essentially means we've got a log, the first expression, which is 10 minus 20x, all divided by basically x squared. I don't know why I'm doing this to myself. Let's just remove the brackets. They are not necessary. So this is just the log of 10 minus 20x over x squared plus 2 is equal to 1. Now we convert to exponential form, right? So this means 10 minus 20x over x squared plus 2 is equal to, now the base takes its position, the exponent is pushed. So u10 lo lapha uyibase uzawufika thatha i-basal position, then i-exponent ixhume yepha njenge-electron xa excited. Electron iyaqumpa izawuqumpela phezulu. Sibe sesiba nantoni? Absorption spectrum. So this is over 1. And we know this gymnastic now comes into the 4. Okay. So this implies we multiply this by 10. So what do we get, guys? We get 10x squared plus 20 equals 10 minus 20x. Now we write our quadratic in standard format. We will have 10x squared plus 20x. 20 minus 10 is going to be plus 10 equal to 0. We divide by 10 throughout. We get x squared plus 2x plus 1 equal to 0, which implies we can factorize x minus plus 1 plus 1. Therefore, we can see that essentially x is minus 1 because there's equal roots here. Now, we need to check the solutions. So we can write here, check. We know that log of 10 minus 20 into minus 1 minus the log of minus 1 squared plus 2 is equal to what? Put it on the calculator, guys. The left hand side must be equal to the right hand side. 2, we need to see that the log is that of a positive value also. That's another thing we can know we're doing the right thing. So let's just do it. Log to the base 10. Remember, when the base is not written, it's 10. Or you can even avoid that one. Just write log of 10 minus 20 into minus 1. But be careful with brackets now in this case. So log of minus 1 squared plus 2. Isn't it 1? Yes, it does. Is equal to 1. We can say, therefore, the left-hand side is equal to the right-hand side. Also, the log, we can say also the log of 10 minus 20 x and log of x squared plus 2 are both okay, what am I saying? No, also let's answer this nicely. Singaphendula mafinyila. Okay, so we know that basically 10 minus 20x as well as x squared plus 2 are both positive numbers, which makes logs valid, or the logarithm valid. So guys, when you're asked a question like this, you need to be very careful on how you present this answer, because you will go down by the head having done everything. Now folks, what are we doing here? Using the law, that is good. Using yet another law, that's good. Factorizing, that is good. Finding the solution, that is good. And proving that the left hand side is equal to the right hand side, that is good. And this explanation is also good. How many marks now? 1, 2, 3, 4, 5, 6. Where is the 7th? We can say here substitutions. We can think about them, or we can think about writing the equation in standard format. So any one of these will give us the extra mark. Okay, so if you don't do these things, ndiyakuxelela uzokhala inyembezi. And ke into endihlekisayo ngeenyembezi, uyayiqaphela into yoba iinyembezi ngamanzi nje anetyiwa, ayilogazi. So kwake kutshiwo ke thina ke sisebancinci uba xa ulila nje ulilela ububhanxa, vele kuthiwe ulila nje amanzi anetyiwa, ulila igazi, because ke besisazi uba nethi ulahlekelwe ligazi ungafa. But amanzi anetyiwa azawuphinda abuye kwedini, ngoba uyayitya ityiwa uphinde usela amanzi. Uyayifumana le nto injalo ke ngoku. Okay guys, so this was just me trying to give you some intelligence on some very important aspects of algebra, so that you don't just practice the easy question 1 questions, you know, in normally paper 1 maths, so that you get used to different tastes and flavors of algebra, because any one of them can pop up as an extra question there to the standard questions that you normally see. Or it can be some tricky question in some other areas where this applies. So be familiar with these kinds of things so that you don't mess up. Okay. Otherwise, guys, leave a thumbs up and I'll see you some other time. Goodbye.